Welcome to my presentation, Cooling as an Integrated Part of the Fourth Generation District Heating. My name is Otto Guðmundsson and I work for Danfoss. Most of you have for sure seen this figure here to the right about the generations of district heating, where the key themes include secure energy supply, local renewable energy sources, sector coupling or smart energy systems. But there are emerging themes as well that we need to consider, like cooling demands and open access district heating. And in those emerging themes, that's where this presentation fits into. Now, district heating is on the rise in Europe. We are seeing more and more district heating being developed in existing district heating markets, as well as increasingly in the southern regions of Europe. And the more south, the milder the winters and warmer the summers. So new systems, they simply must consider cooling demands. On top of those, we have a changing demography in Europe. We have an aging population, which is then less capable of handling the extreme temperature during the future in the summer. But we also have an increased comfort demands in general. But it's not only that district heating systems are being built in Southern Europe. Due to climate change, we also foresee a general increase in summer temperatures, as is shown here to the right. So there is no question cooling will be increasingly important. But also new buildings are becoming tighter and have more windows or bigger windows. And both of those leads to overheating in summer. So we can actually conclude that cooling demand will even increase in the future. Now, building thermal demands in Europe are heating dominated. This is the case today, as we can see here on the right. But also, if we look into the future, it is the same. We will have slightly less heating demand, but we will also have more cooling demands. Nonetheless, it will be heating dominated. And according to the Heat Roadmap Europe, there is more waste heat available in Europe than is needed to cover all of EU heating demands, so for the building heating demands. And this just underlines that district heating is and will be highly relevant. It just needs to evolve to have comfort cooling as an integral part of its service. But why should we consider comfort cooling and what are the benefits? Well, the benefit for the end user to couple the cooling with the district heating is that they will have sustainable and low cost heat during the heating season through the district heating system. They can have a simple cooling add-on to their existing district heating substation, and that means there's no need for a potentially costly installation of external fan coil units to get rid of the waste heat. And as a consequence, there will be no disturbing fan noises. And if it's integrated into the existing heating installation, then there is a possibility to use the waste heat for domestic hot water purposes. As for the district heating utility, they benefit from the fact that if we have a comfort cooling as a general trend, then there will be new heat sources distributed all around the distribution system, and this will increase the energy supply security and as well resilience of the system. But it opens up the possibility for potential new business models and services by the district heating utility. If we look on the society, then if we can get rid of those fan coil units, then we have better looking buildings and we will have less noisy neighborhoods. The waste heat, as I mentioned before, if we can use it by other users, then it's just fantastic and the distribution system can enable that. We can also minimize the heat island effect because we are avoiding uncontrolled heat rejection. And that is not only when the waste heat can be used by other users, but it's also if we run into a situation there's more waste heat than heating demand in the distribution network, then at least the district heating utilities have better possibility to use alternative heat sinks than building owners. That can be rivers, lakes, sea, underground, or simply move the waste heat out of the city centers and dissipate it more and closer to the urban rural areas. Now, how would we integrate this into the district heating substation? Well, first, if you take the very basic, then when we have a district heating, then we take that into the district heating substation and we use the heat to supply for space heating, for example, in underfloor heating, or alternatively for domestic hot water purposes. If we add the heat pump, then the evaporator side will make sure that we get a cooling, and we will repurpose the underfloor heating tubes so we have underfloor cooling. And then on the condenser side of the heat pump, here we have the option that if we have it in operation, we can store the waste heat in, for example, a thermal storage tank. And when we have some demand, like domestic hot water demand, we can simply take the heat and supply it for our domestic hot water purposes. On the other hand, if we have more waste heat than we can use by ourselves, we can potentially export it to the district heating system. If you look on the thermal comfort, then of course it depends on multiple parameters. Depends on the humidity, airspeed, air temperature, radiant temperature, the metabolic rate of the occupants of the buildings, and the level of clothing. And if we have floor cooling as is considered in this presentation, then we are basically influencing the radiant temperature of the floor, and as a consequence the air temperature. But we have a limitation, because we need to make sure that we don't run into a situation where we get condensation on the floor. So the humidity is a relevant parameter that we need to consider and monitor. We have made a proof of concept at DTU Mac laboratory, where we tested a heat pump module with 3 kilowatt cooling capacity, as is shown here on the right side. The system is set up with a design operating temperature of the floor cooling at 17 degrees supply to the floor cooling and 22 degrees return. And on the condenser side of the heat pump, we assume that we have a district heating with a return temperature of 40 degrees, and run that into the condenser and get out 60 degrees. The COP for the cooling is not particularly high, 2.4 to 2.6, but we need to keep in mind the purpose is to have a useful heat as well. And the COP for the heating was measured between 3.2 and 3.3, so the combined cooling and heating COP was between 5.6 and 5.9. Not so bad. There are some basic challenges that needs to be considered. For example, how does the district heating utility see those small prosumers? Are they willing to provide payments to the prosumers for their waste heat? Or might they offer a service to take the waste heat for free? Or alternatively, they could put up a fee for removing the waste heat. But exporting the heat to district heating system has some challenges as well, because we are most likely operating with low flow levels at potentially high differential pressure in the distribution network. And this generally means that the pump will have a low efficiency, maybe down to 10-15%. And since those operating conditions are out of the norm for district heating pumps, then we need special pumps, industry pumps, and they can be a little bit expensive. The next steps that we are seeing is to demonstrate the concept in a Danfoss test house in Aalborg, where the waste heat from the cooling operation will be put into the local campus grid and hopefully used by the Danfoss buildings. Or if that is not possible, because there is a lack of heating demand in the campus, there is a possibility to export it to the local district heating network. We further plan on analyzing the impact that the waste heat from many small cooling users might have on the district heating system operation. But that is a story for another day, and this concludes my presentation. So I thank you for your attention.